Hey guys, welcome to DSA-n-Design. Today we will look at how to remove a cycle in the linked list, right? In previous lecture we have looked at how to basically detect a cycle and then we will go ahead one step ahead in this lecture and we will try to see how actually we can remove a cycle if it is present, right? So for example, okay, so what we want to do, how to remove a cycle or loop, right? In linked list. This is what exactly we want to do. All right. So let's try to understand first basically and approach basically. That is most important thing, right? How exactly we will see that using the Floyd's method, how exactly we can detect and how we can remove it, right? So we will use basically Floyd's algorithm. This was given by Floyd, right? And then what he says is basically, let's say I have this linked list maybe, all right, and something like this, and they are basically, let's say I have these 5 nodes and this is basically linked to this, for example, right? And this is n1, n2, n3, n4 and 5. These are the nodes. Value is 10, 20, simple, 30, 40 and 50. All right. Now obviously if we can see it, there is a cycle present, right? Because this n5 actually is pointing to n2, which means basically I am looping round and round. Once I start from here, right, I'll start and I'll go here, and then from here onward it's basically looping like this. Correct? You can see it, right? So it's basically never ending loop, right? So we are actually stuck in a loop. Now what we want to do is we basically want to actually detect first, right? And then we want to remove it, correct? So this value was what? This was actually 50, yeah. So we want to actually detect. So first of all we have to find it where there is a cycle, okay, then only we have to remove, right? Otherwise if there is uh, no kind of cycle, then what is the use, right? For example, if you have, let's say, normal linked list, right, 1 2 3, maybe these nodes, right? So this is n1, n2, n3, 10, 20, 30, right? And this is basically pointing to null node, right? There is no problem, right? I mean, this is a normal linked list only, right? So simply what I will do, I will actually return the head, right? So in this case we have to find out if there is a cycle. Then in that case we have to go and remove this particular cycle. So where exactly is the cycle forming? You can see it, the n5 actually is pointing to n2, and this is the thing that we have to break basically here, right? And then my linked list will be what? It will be kind of 10, 20, 30, 40 and 50, and this linkage will be broken, right? This is what we want to do. And finally what we have to do, we have to actually return the head node, right? Anyways we have to return the head node in if there is a cycle present or not. Here also we have to return. If there is no cycle present, nothing need to be done, just return the head node. If there is a cycle present, we have to first break this one, this particular, the cycle, and then return the head node, right? This is what exactly we want to do. Okay. So let's do one thing. Let's try to understand first little bit about this cycle, right? We have looked at in the previous session, but let's try to understand little bit more about it, right? How exactly we can actually detect a cycle, right? So let's say these are my, I'm just taking this example, okay, where I have in this time this is basically pointing to this. So this is, let's say, 10, 20, 30, 40 and 50. All right. I'll give the name, yeah. So this is very easy, actually easy to refer, right? N1, N2, N3, N4, and 5. All right. Now in this case, we can see clearly that N5 is actually pointing to N3, which is how actually there is a loop forming here, right? Now I have to find out where exactly, right? Where exactly is a loop? I mean the loop starting, right? So this is the place where the loop starting, and if I can actually break this particular loop, what I have to say here. So first of all, okay, let's try to understand step by step, guys. Okay, first let's try to find out whether there is a cycle or not, right? We have looked at in the previous session, but let's try to look once again. Okay, what I will do, what I said, this is my head anyways, right? I will actually put two pointer, one is slow pointer, one is fast pointer on the head. All right. Fast pointer will be moving two step and slow pointer will be moving one step. So let's try to move it actually and then see the moment. So there actually fast pointer two step, right? So fast pointer will be running very fast actually and it will be looping in actually after this, right? It will not go here. It will rather actually start traversing within this loop itself, right? Slow pointer will be coming little slower, but this eventually the slow pointer will also start looping in this one, right, after some time, and there will be a time definitely when slow pointer and fast pointer will be pointing to only one place, which means there is a loop, right? That is how, otherwise fast and slow will never meet. If there is no loop, fast pointer and slow pointer will never meet. For example, if there is no loop, then actually fast pointer will actually go to the last node automatically uh, before slow pointer actually is still traversing, right? So if there is a loop only, then fast pointer and slow pointer will be meeting, right? So we have to check if fast pointer and slow pointer both are same, then I can say there is a loop, right? This is what we have looked at it. So let's try to understand theoretically here first. Okay, so let's see. Okay, slow pointer one step, fast pointer I'll move two steps, so fast pointer here, again slow step, one step here, uh, fast pointer it will move here, right? Now again slow one step, fast two steps. You see very beautifully it is basically meeting at n4, right? Both of them are actually meeting at n4. Now what I will do, this is, so now I know that there is a cycle present, right? If there is cycle present, then I have to actually remove it. To remove this, what exactly I have to do? Somehow, right? Somehow I have to reach here actually, right? Let's do one thing actually. Okay, what we will do is, what I say is I have to break this node, right? I have to break this node. So can I say that n5, right now n5 equal to next equal to what, guys? N5 dot next equal to n3, isn't it? This in this case, right? So n5 is actually pointing to n3, isn't it? But what I want to do is I want to point this n5 dot next to null. The moment I say n5 dot next equal to null, this link is broken, guys, right? And this is exactly what I want, right? This is exactly what I want. I want to do it, right? But before that, I have to make sure I reach to this position, right? And how do I reach to? How do I know that I am reaching here? So one thing is there, right? the moment the moment what I will do is I will actually, so okay, so let's try to do one thing. My idea is I will say, can I say something like this? If my n2 dot next equal to n2 dot next equal to okay, so this one basically, right? Okay, this pointer, I want to see that where is my starting point, right? So before that node, okay, I have to go. So this is my starting point, starting of the loop, right? This is the starting of the loop, right? So what I can say is n2 dot next equal to n5 dot next, if both are same, right? So n2 dot next is this node actually, n5 dot next equal to this node only, right? If this is the condition, if this is the condition, okay, then I can say n2 n5 dot next equal to null. Simple, right? And this is basically I want to find out, right? Agree, right? So for this, basically I don't need to worry too much about it. What I have to do is I have to simply apply the Floyd's rule and I have to trust on the Floyd's rule. That Floyd's rule is actually helping me to remove this cycle also, right? Now we know that how to actually find out basically there is a loop. Okay, now I know that I know that I have a loop basically. Okay, now what I will do is let's try to okay, use this diagram itself. Okay, all right, guys. Now, okay, let me one second. So where exactly? Okay, I think we were. It was meeting here, no? It was meeting S equal to F. This was the place actually, right? And then that's how we say that the cycle is present. Cycle is present. Correct. Now, what I am saying is, uh, to remove the cycle, I have to do step one, first one, right? So step one, find if cycle is present. Correct. This is what I have to do. And in this case, I know cycle equal to yes, it is present. Okay. Now my slow and fast pointer are actually pointing to certain place. Okay. This is my node actually. Okay. What I will do, I'll take two more. So now second step, no? Second step is basically to remove it, right? To remove this particular cycle, I have to actually trust on the Floyd's method. Okay. Floyd's algorithm. Floyd says, now once you find this cycle, make two slope pointers. So I will say S1 equal to head. S1 should always be actually pointing to head again here. Okay. We will see that how it works. And now S2 should be actually the slope pointer, which was actually here, the meeting point, right? This one. This was the meeting point, no? So S2 should be this one. And then I say that, okay, you continue to move, until you find S1 dot next equal to S2 dot next. The moment you find these both of okay, if it is not until then, the moment actually both are same, S1 dot next, which is basically we'll see that this is the point actually S1 and this is S2. Okay, let me take different color, guys. Okay, then it will make more sense actually. Okay, all right. Just try to understand first concept, guys, right? So in this case, I said make S1 as head, okay? But you traverse it and then you find S1 dot next is equal to S2 dot next. That point of time, I have to come out of the loop, okay? I have to come out of the loop and then I have to say S2 dot next equal to null. That's all I have to do and return head. Okay. Because see, this is my S2, let's say. S2 dot next equal to this and S1 is here. So S1 dot next is also this. So this particular node N3 is going to be same. And that point of time I'll come out and I will say N2, N5 dot next equal to null, right? Let's see that how it works. Okay. So let's take this example. Okay. Okay. I think okay, let me do one thing, guys. Okay, let me take a fresh diagram. Okay, we have to just actually understand this Floyd's concept, no? Okay, I think I want to just make sure you understand it very very clearly, right? So let me try to take again the same example which we are comfortable with, right? Now let's say this is 5, this is okay. Let's do quickly, and this is basically here. So it is 1, 2, 3, okay, 10, 20, no? These values actually, let's put 40 and 50. Okay, in terms of node, this is N1, N2, N3, N4, N5. All right. Now what we say, actually while traversing, we found that slow and fast pointer, no? Slow and fast pointer are meeting at this point of this point actually. Okay, this is the node where, and this is my head node obviously, right? Now I found this cycle. Now what I will do, Floyd rule says that to remove the cycle I have to make two pointer. One is S1, S1 will be actually head node, and S2 will be what? S2 will be S, means this one basically. Yeah, so here is, let's say, S2, here is S1. Agree? Now what I say is I have to continue travel and I have to look for this condition, S1 dot next equal to S2 dot next. Until we meet this condition, I'll continue to travel. Okay, so let's try. And this will actually slow pointer, no? So it will move one step, right? So let's move one step here. This is S1 now, and this will move. It will be S2 here. Now what I say is, I say S1 dot next, which is basically this, right? S1 dot next is this, and S2 dot next is also this particular node. You see that, right? That's how this condition is met. I will actually come out of the while loop actually. Okay, this is my while loop, right? I'll come up the while loop and simply to break this rule, I will say S2 dot next. What was this before? s2 dot next equal to what you say, n3, no? This time I'm saying s2 dot next equal to null, and this node, this particular link is broken. That's all, and I will just simply say return. One second, guys. Sorry. All right. Okay. Something. Okay. And then I'll simply return head actually. Okay. And to dot next equal to null, and then I'll simply return head. This is 100% proven method basically by Floyd to remove the cycle, guys. Okay. So let's try to see how it can be coded. I have already coded it so that I can just walk you through by the code and I'll run it basically and then see it, right? Let's try to see this. So what I have done, I have created a kind of method where I say remove loop from the linked list, right? And I'm actually going to return the head node actually after removal, right? So what I have done is simple, slow and fast pointer. Just to detect a cycle, I have taken a boolean. This is the new old code itself, what we have looked at in the previous video, right? And now after this, right, I am actually setting up if in this case actually I'm just trying to find out, where if cycle is there. Now after this while loop I'm coming out and I'm checking if cycle is false. If there is no cycle, so there is no need to do anything. I'll simply return head, correct? Because no need to remove the cycle itself, simply removing returning the head, right? Else if there is a kind of cycle, in that case I have to do these steps actually, right? Find the starting point of the loop. So how exactly I find a starting point of the loop, right? Now I will say, as I said, right, I know that where exactly it is meeting. That's why I found my kind of cycle, no? So slow and fast I can use it here actually. S1 to head and S2 to slow. What is that slow? Basically this one, right? This one actually, okay? And S1 is the brand new one, right? So two slow pointers I will take, and then I will traverse up to S1 dot next equal to S2 dot next here, right? Here let's say S1 dot next equal to this node and S2 dot next equal to this node, right? So I will actually traverse until these two conditions are met. It is not there. If it is not equal to, until there I will traverse, and I will travel one step actually. S1 will be traveling one step and S2 will also travel one step, right? The moment this condition is false actually, I'll come out of it and I'll say S2 dot next equal to null. This is what we have done, right? So S2 dot next equal to null, which means I'm actually breaking this particular link, right? And after breaking I'll just return the head node, right? This is the code actually, guys, and this is very famous interview questions. I think you should be actually practicing this, right? And yeah, so that's what I wanted to cover this in this video. And what I will do is I'll quickly run it and I'll show you actually how it works, right? So for example, I have a linked list which doesn't have any loop. For example, in this case, after and before should be same, right? So let me print it actually. Okay, let me try to print this one. 1 second, guys. Just give me a second. Okay, I'll just run it. Let's see. All right. So if you can see it, it says that linked list. I mean, this is the before one and this is after one. Actually, I'm just printing the whole linked list because I return the head node, and based on the head node, I'm printing it, right? Now, for example, I have made a loop now. N1, N2, N3, N5, and then N5 is actually pointing to, for example, something like this N3. Okay. So let me make N3 rather than that actually. Okay. N3. Now there is a loop. Now if I run this, in this case, before removal, no, it will go to infinite loop. Okay, so let's try to see if it is going to infinite loop actually before breaking, right? Now let's see. You see, this is going to infinite loop because it is actually running in loop and loop, right? That's why I have to stop it actually, and I will stop printing this first of all. I'll not print it. Now it will not go, right? Now I'm actually having this kind of linked list which is having loop. Now I will break in this one. I am going to remove the kind of loop, and then I am returning the head node, and based on the head node I am again printing it, right? So let's try to run it basically, what we get it. You see, guys, 2 5 10 don't, I mean we have actually broken that link basically, and after that we are removing it. So this is after that, right? Link after removal, right? If I, so before that I cannot print it because I just showed you, right? It is actually going loop and loop, right? That's why I'm not printing it here, otherwise it will go in loop and it will not go further. That's why I just commented it. But after removal, you see this link list is coming very nicely. Okay, so that is how actually you can do it. So this question, this kind of things actually you can, if you not very sure how to actually detect a cycle, I have written a code before, and the same code I have utilized here basically. Majority of the same code to up to here at least, right? To get whether there is a cycle or not, right? So this particular code is reutilized. First detect the cycle and remove the cycle, right? That's all for this video, guys. I'll not take any further time here, and I hope that this really makes sense. And if you're first time on this channel, please do consider to subscribe this channel, and I'm going to put a lot of more interesting videos on various other topic on the data structure. And currently we are learning the linked list. We are going to learn in detail, right? So, and please do share, subscribe, and like and comments as well, right? And that is how you can support me, right, to do bring this video, this kind of content to you guys, right? So thank you for watching, and I'll see you with the next video. Until then, happy learning. Bye.